All right, let's go ahead and get started. We have quite a few people with us here today. I am Mark Piller. I'm the founder of Backendless. We're talking about building a scalable app. It does not have to be with Backendless. Of course, we'll be taking more of a Backendless view of the world and building applications, but a lot of things that I will be talking about, they are rather general, specifically when it comes to building a scalable application. I'll be answering questions if you have any towards the end of the webinar, but feel free to post your questions in the chat pod of Zoom. And let's go ahead and get started. So before I proceed, it is rather hard for me to talk today without acknowledging a terrible tragedy that is going on in Ukraine today. A completely senseless loss of life. We have a lot of people in Ukraine who work at Backendless, a lot of friends and their families. Everyone is impacted, and it is absolutely terrible what's going on. And our hearts and minds are with everyone who is fighting this terrible war. If anyone wants to help, there's a link on your screen that I know you cannot click it, but it's a fairly simple link. If you go there, you can actually donate and help and show your support to the people of Ukraine. All right, now let's go ahead and get started. So first of all, what is scalability? I think everyone kind of understands what it is, but I tried to put it succinctly to specifically what scalability really means in terms of software and applications. And the way I put it is basically it is an ability to function when the size, it actually should be size or volume changes. And that could be the size of data, could be the size of files, could be the number of files, or it could be the volume of requests that are coming to the server. So being able for the application to function when those changes occur is what defines scalability. And some of these things could be in your control. Some of these things could really come from the platform or the system that you're using. And in this webinar, I'll be talking about both of what to look for in the platform when you make a decision, what you're going to be building your application with, and then also some of the things that you need to keep in mind and apply in the design of your application and in the architecture of your application that will result in significant scalability when it comes to launching and running your application. So specifically with scalability, I guess a good definition of it would be, just putting it in perspective, is when you have one user and everything's just running smoothly. Data comes back, you can render all the data on the screens, whether it's the browser or mobile screens, and everything looks great. And then you have 1,000 users, 100,000 users, million users. So when the application continues to run the same way as it does with one user, you can basically say that it scales rather well. And the same thing goes for the actual data that is accumulated by your application. You could have an application that has, 10 users, but you have millions of records in the database, or you have millions of files that you are working with. And in this case, even with an insignificant number of users accessing your application, if they can get data quickly and if they can perform business functions of your application, then you can say that it scales. So here I'll be looking into both of these things. So a lot of people, and I know we have a lot of people who come here with a background of developing applications with no code, although the majority of things that I will be talking about, they are not necessarily related to no code. But specifically coming from the no-code perspective, there is a certain sort of stigma or kind of an idea that no code does not necessarily equal, or sometimes means that it doesn't really scale. And that could be true for some systems. However, with backendless, the way we take and the way we see no code is really just another way to express your logic that runs in your application. The actual system that we build, and I think that would be a good example for a lot of other systems, the actual system does not make any assumptions that you are going to be building the system, building your app with no code. In other words, speaking of backendless, it will run exactly the same way, whether your application is built with code or built without any code, where you use logical programming. So in my mind, no code really is just another way to interface with an application to describe your logic. And then any other system that basically says we're no code and that's how you do it. And because of that, here are some other things that will happen. I believe it just takes this approach, has a wrong approach in my opinion. So scalable UI and scalable backend, in my mind, are different things. So a UI produces an application that runs on an individual device, right? So whatever a user sees on the screen is the UI. And that becomes really just one instance of your application running on a specific device. How you build that UI, whether it's with no code or with code, still means that there's going to be the X number of cores on that specific device that powers up your application. However, UI drives the data volume. It means that whatever logic that you put in the UI, that will result in how many requests are going to be sent to the server. And that becomes an interesting thing, because if you have 1, 10, 100,000 million of users, whatever number of API calls or requests that individual UI instance produces needs to be multiplied by the number of users. And that becomes the volume that the server needs to handle. So the scalability of that volume really lies on the server. The server should be able to handle that volume. However, the design of the UI is also very important, because it is where the actual volume is being driven from. So designing your UI in the way where it where it drives the logic of your application in a way that does not overpower the server, it becomes very important. And the true scalability really lies with the server, in my opinion. So the backend becomes a significantly more important element of a scalable application than the individual front ends that hit that backend. From that, one of the conclusions that you can make that, for some users, they log in and they have a lot of data. And then if the UI cannot handle a lot of data, let's say server served up all the data, and it comes back to the UI, and the UI cannot render it all quickly, or just, uses up all the memory, that will impact those users. For other users that do not work with a lot of data in the same application, the UI can continue to function. So scalability of the UI will impact some users, and then scalability or the lack of scalability of UI. Likewise, the lack of scalability of the backend will impact everyone. And the interesting thing here is, a lot of people focus on building beautiful UIs and creating fantastic user experience. But if it runs on top of a backend that doesn't scale, your investment into building that beautiful UI will equal to absolute zero if the server crashes. So that's kind of the essence of why scalability is important. Let's dig a little deeper. So here it says your no-code backend, but it really is just any backend. So a true backend that provides an ability to build applications more than likely will consist of all of these blocks. In case of backendless, it definitely consists of all these blocks. These are all the individual elements of the backendless backend. But there are systems out there that provide somewhat similar functionality, or you can combine multiple systems that provide this functionality combined. And scalability really applies to pretty much every single block here, because with the rule of size or volume, every single element here would be susceptible to that rule. And it would be important that every single element of this diagram needs to be scalable on its own. And of course, there are different layers sitting on top of it as far as, how requests are being routed or queued or handled, or how the system can become more elastic just to apply additional resources to handle any kind of traffic. But here are the individual elements. So for some of these, you can control the actual layout and structure of that system. For many others, it is just whatever the backend can do. So for instance, if you take push notifications, of course, you can design what a push notification looks like, what it consists of, and then whether it has images, text, whatever, buttons, but it would be entirely up to the design of the backend to handle the delivery of tens of thousands or millions of notifications to your individual users. And there is really nothing that you can do if that system or subsystem of, let's say, push notifications was not built to handle it, then it doesn't matter. It will just not scale. So there's really an element of where the responsibility of the platform stops and what you can do. And first, for some of this, you can do a lot. For many of this, you really cannot do anything if the backend doesn't really scale. Specifically, these three blocks, database, file storage, and API services, is where you can make direct impact on making it more scalable or less scalable. And these are the things that I want to look into in this webinar. We'll start with the database. So things to look for in a database that will make it scalable. And these are all the individual things that I have identified. So with data types, the richer data type support means that you can identify how much data each individual element can hold. For instance, if a database is more primitive and where everything is either just strings or numbers, that means that for a lot of data, for a lot of different data types, well, overloading the term here. So for a lot of data, there will be a lot of data space allocated where it's really not needed. And when a lot of data space is allocated, it will impact scalability. So if you have specific data types for dates, for booleans, for strings, for numbers, for currencies, for identifiers, that will drive the scalability of the entire system. Support for relations, I believe, is absolutely important, and we will talk about it in detail for the reason that it really helps to denormalize your database. And what it means is that you can create those islands of data that is related to each other, where you can load only the data that you need. And if there is related data, you can load that as well. But if the relations are not there, or if they are very primitive where you do not have full control, that means that you will either be loading a lot of data that you don't need in a single request. Thus, you'll be penalizing the database by putting more load in this, and you'll be penalizing the UI by retrieving more data that it really needs. So relations are extremely important when you look for a scalable solution in a database. Support for queries, and I put it as rich query support, the third bullet from the top. It is important in a way where you can drive and dictate what data needs to be loaded by identifying the data specifically with a query. If the query format and the support for queries are such where you cannot identify that you need that specific element of data or that specific relation, or the data that conforms to certain rules, once again, it will result in loading a lot of data that is not necessary, and that will penalize the overall scalability of your application and specifically user experience, because the UI is going to be handling a lot. We'll have to deal with a lot more data that is really not needed. Restrictions on the data sizes is important because, again, by applying those restrictions and saying, okay, well, here's a column in the database that contains names. And the longest name that you could have would probably be, if you go absolutely crazy, like maybe 60 characters, first name, last name. If it is more than that, and if you allocate the entire 250 characters or even more, that means that you're allocating more space that is needed. And in the long run, once you start accumulating a lot of data, that will result in the system that doesn't really run smoothly. All right. Just want to make sure that, yeah, okay. Just wanted to confirm that you can see and hear me. Otherwise, I would hear from our guys. Anyway, non-relational data support is also important. Sometimes, in certain cases, you have situations where you are dealing with data that is not structured, and being able to save the data and query it and retrieve it is also very important. And in most cases, this really results in being able to handle JSON objects that are stored in the database. Transactions are extremely important for the reason that as your application starts doing more complex stuff, where you need to run a series of operations on your database in a single request, and if something goes wrong, the whole thing is rolled back, which is the essence of transaction. Or if everything goes well, the whole series of operations are committed to database. That's also quite an important feature to look for. Management functions is being able to work with your database through some management UI, some sort of graphical tool where you can interact with your data. And again, from your application perspective, the entire process is driven by the APIs. So the APIs need to be flexible, they need to be accommodating, you need to be able to use the APIs in a way that really reflects what the application wants to do. Whenever we get a question, or whenever we start working on an application, because we do some application development as well, we follow the approach of the UI design first. And I believe that following that approach is really the way to go. There are different schools of thought. Some people say that you have to start with the database schema and design it first. I actually disagree with that approach. I believe that if you start with the user experience and the UI first, that will help in the entire process to build an application that is just better built, it's more responsive, it is architected in a way that you can start expanding it better, and it will be more scalable. So with the UI first approach, the way we approach this is we start with the actual mockups, storyboards, whether it is maybe Figma designs, but basically anything and everything that depicts the actual user experience, capturing everything that the user sees on their screen. Okay, and you start from there. Okay, so by putting it on the screen, in the form of mockups or designs and whatnot, you can go through pretty much the entire data flow and identify all the important elements that will really drive the rest of the application. And the rest of the application really means putting together your schema, identifying any kind of business logic that needs to run, compartmentalizing that business logic in terms of in the form of API services, assigning roles and responsibilities of who does what, and with that, the rest of the design of the application kind of flows. And here in these steps that I defined on the screen, they kind of they're still at a very high level, but they really define the steps that we follow whenever we start thinking about the design of an application, whenever we build one. Let's see. Let's take an example of, let's say, something like Uber Eats, because it's a well-known concept that everyone understands what an Uber Eats-like application looks like and what it does. So here, if we were just to look at these screens, and let's just say this is not a real application, this is just, let's say, a design from Figma, which I think what this screenshot is where it was taken from. So just by looking at these screens, we can identify some core entities that exist in that application. And namely, we can see here that we have cuisines, which is the very first screen that identifies various cuisines. For each individual cuisine, we have a collection of dishes. We have a concept of a map, where is that map? I guess it's right here, this little icon where you can look for various, I guess, restaurants on the map. There is a concept of a shopping cart. So these are like the first things that pop out at you when you look at this. So what it means from the design perspective and how you start driving the design of the rest of the application, you can start digging deeper and then look at the specific, let's say, what a dish entity consists of. And just by looking at this screen, at these screens, we see that a dish contains title, description, price, picture, and there's the picture gallery. So with that information, if we move on, we can actually start putting together a schema. And we can start defining data tables and assigning individual columns that would be mapped to properties in the entities that we design. And here we can actually start building relations, because we know that a cuisine has a collection of dishes, or in this case, it is actually a dish can belong to different cuisines, which is also quite right. Or whatever the relationship is, you basically define the relations. And by doing so, you can see, how the data would actually be retrieved and put into the database, which is one of the steps that I described earlier, that talks about, how the queries will actually work back and forth from the UI to the backend. Okay. Why is this important? Well, because once you lay it out in the database, that's going to become the core of your application, and you will need to start thinking, okay, what are going to be the weak spots when you think about the growth? Okay, so for instance, if we have millions of users, or what the system grows where it has tens of thousands of different dishes, how fast will those queries be when we need to retrieve those dishes? Like, for instance, if the actual users table grows to millions of users, does the use case exist in the application where we need to load all those users? No, it does not. Okay, so there's really no weak spot where you have to load tens of thousands of individual records. In fact, speaking of loading tens of thousands of individual records, this is something that a lot of people struggle based on the questions that we get. It's like, I need to load all the data. And there are very few cases. They still exist, but there are very few cases when you actually need to load all the data from the database. But we'll talk about this and in one of the slides that is coming up. So you define the schema, you define the relations. That becomes really the core of the sort of the map of your application captured in the database. Okay. Once you have that schema, you can start identifying the spots that will impact the speed of your application and scalability. Okay. So namely, they are database column count. If you notice that your table grows to the point where you have so many individual columns, and you can actually put quite a few columns, let's say with Backendless, you can have more than 100 individual columns in a single table, to me, that would be a warning sign. Okay. There are some reasons why you may want to do it, but more often than not, there's really no reason to do that. Relations really come to help to denormalize it. So if you have come up with a schema where you have quite a few columns, rethink that. Do you really need to have all of that data in there? Are there use cases in the UI where you need to have all of that data at once? If the answer is no, rethink and refactor your schema. Okay, being conservative with the design, meaning that conservative in terms of the number of columns, is important. Okay, it is better to have more tables and fewer columns and link those tables together through the relations than the other way around. Okay, sometimes, and I think that I talk about it, actually, I'll get there. So sometimes when you have a related table and you do not always need that data, it's okay to keep the data in a related table and get it only when you need it, rather than getting it at once. Here's an example of that I actually took from one of the real applications in Backendless, and you can see here a screenshot of the users table that contains so many different columns that in my mind, it is just incomprehensible. I cannot imagine a use case where all of this would be needed in a single table, okay? And then the number of relations is also astounding. So this is a good example of the things not to do, unless you absolutely need it. Once again, I keep saying that there are use cases when you may need it, but they are really in the minority. Other things to consider to increase the speed of just how fast the database runs is indexing. And in Backendless, turning on indexing is very easy. If you go to the schema tab, you can select a column and just say that it is indexed. What does it mean? Well, an index is something that happens inside of the database where the database itself just kind of does this full scan and creates some additional resources that basically says that if I'm looking for this, this is how you can find it in the most primitive terms. It really is just an additional mechanism of lookup that the database does to find things better. Applying index to absolutely every single column is going to be suicidal. It will not give you any benefit. In fact, if we notice that you're doing this, more likely you will get an email from Backendless saying, hey, you're abusing the system. So indexes really should be applied to the columns that you search by most. If you're applying an index to a column that you never search by, you do not need that index. And indexing really should be turned on once you have, I'd say, something more than 100,000 records. Because for anything less than that, the database can do the job just fine. What does it mean to search by a column? So whenever you retrieve data from the database, if you identify specific properties in your query, like whenever you want to find something where the name equals whatever, well, that name becomes a searchable column. So you want to apply and then the index to that. That's going to be an example of applying indexes. Okay, so this is what I was talking about earlier, having relations versus not having relations. So for instance, here we have on the left-hand side, we have a relation between dish and cuisine. And this relation goes from dish to cuisine. I'm not sure it's this way to me. It could be argued whether, cuisine contains dishes or dishes belong to cuisine. Either way, it doesn't matter. So if you are loading an entity or a collection of entities, and you notice that every time you load dish, you also load cuisine, every single time. Okay, so you're basically just attaching that relation. And you never load cuisine separately. That would be a good case for merging those columns together. And by doing so, you result in the table that is on the right-hand side, where the columns from cuisine, got moved into the dish. This way, everything is in a single table, and in that case, it may be okay. However, let's say if we go back to the Uber Eats application, I don't think that would be okay, because the concept of cuisines exists separately. There's a separate screen where you load all the cuisines. But if you were to kind of mentally apply that to your application, and you know that you load entity A, but you always attach related entity B regardless, and it's always there, keeping it separate may not necessarily be a good approach from the performance and scalability perspective. Generally speaking, relations, if you were to load a lot of relations, it will be a little bit of a penalty on performance. However, if those relations are loaded only as needed, and then typically it happens when you have one screen and you navigate to another screen and then in there you load all the related data, then relations are perfect. Of course, in a lot of applications, you do load some relations. So don't be afraid to do that. It is okay. That's just how systems are built. And the system that we have really supports that scenario, and it does it quite well. But I'm talking about specifically the use cases or the decision tree that you may have in your mind on when you need to merge it into one table or keep the relation separately. And then the good rule of thumb is just seeing if you just always load from that relation and never use it separately, then merge it together. Okay. All right. Another kind of idea and technique, I would say, to use is using integers instead of strings in columns that you search by. Integers are a lot faster to search and do the comparisons at the database level than strings. Here I have an example where the user profile table references and it describes a user profile. As you can see here, we have, their body type, how many children, their education level, ethnicity. I think this is from one of the dating applications. And as you can see, many of these columns are integers. Okay, so for instance, education level is an integer, ethnicity, hair color, even height, political views, religion, sex orientation, all of these are integers. And with these two, hair color and marital status, which is just examples, it points to another table, okay, that contains that information of specific hair colors or marital statuses. And the way this works is that if you want to create a user profile and say that we have a single person with a brown hair color, rather than having a relation, to that table that identifies the, marital status or hair color or their political views, you put in an integer in there. And that integer, there's another table that basically says that if hair color is 1, it is, brown. And if it is 2, the hair color is black. And if it is 3, it is blonde. And by using that approach, whenever you run a search, like find me all the user profiles where hair color is brown and political view is liberal and the education level is, PhD or whatever, that becomes significantly faster because for the database to find all the records where ethnicity is 1 and marital status is 2 and political view is 5 is going to be significantly faster than running these searches of identifying those user profiles if they were relations or strings. Okay, so that's one of the approaches that can be applied to many different areas, but I think in this application it's kind of the one that is very easy to understand. So keep in mind that integers as a mechanism for lookup and comparison are way faster than relations or strings. Okay. All right, some other things to consider. We talked about unstructured data, and JSON is a perfect way to store unstructured data. So in Backendless, you can define a column of the JSON data type and put any kind of valid JSON in that column. In fact, one record could contain, just an array, and the other record in that very column could contain a JSON object. Absolutely possible, legitimate way to use it. Doesn't really make a lot of sense if that's the case, but in some cases it might. I just cannot think of one. But do not overuse JSON. I see quite a few applications that are being built where people create JSON for the reason that it's just so flexible and you can put anything in there. It is flexible. We provide a bunch of functions where you can do JSON searches, but I believe it is just not necessarily the right way to use that specific data type. What would be a good way to use JSON? Well, let's say if you have some kind of data structure that still identifies specific entities. So it could be, I cannot even think of one, but let's say you have some entity that may contain some fields and may not contain other fields for different users. That would be a good example to use JSON. So it's completely unstructured, but has some kind of commonality. In this case, it would be absolutely okay. Another thing that happens quite often, people put files in the database. I don't understand why. I think it is wrong. You can do it. You can definitely define a data type of text, which supports up to 20 kilobytes. We also have another data type that is called large text that can support up to like 65 kilobytes. I think it is only in the pro version, but still, there is this drive coming from somewhere to put files in the database. Files belong to the file system. Database contains data. A lot more elegant approach would be to store files in the file system, and there are APIs to upload files, move files, search files, whatever, and then store the actual URL to the file in the database. This way, you can quickly get the URL and fetch the file. In fact, mobile applications and browser apps will handle that a lot better than just getting a bunch of bytes from a database query. Paging. So paging is something that we built into the system. It's baked into Backendless. And default page size is 100. I'm sorry, maximum page size is 100. What does it mean? It means that if you have a table that contains millions of records, you can load only 100 records at a time. Why did we do this? Number one is because to make it more flexible, to make it more scalable, not so flexible because a lot of people kind of struggle with this. But it really is one of the elements that results in better scalability. If you look at any given screen, phone screen or even browser-based applications, at any point of time, to a human eye, being able to consume more than 100 individual elements, whether they are orders or users or dishes in the Uber Eats application, it would be impossible to consume even 100. And by putting paging in there and by putting a page size of 100, our intent was and still is to force developers to think about building an application where you do not need a lot of data. You basically have this UI-driven design where you show only what's needed at any point of time. Is it possible to load all the data? Yes, of course. And in this case, the general approach that we recommend is to create an API service, run multiple requests, accumulate all the data that you need, do the processing, and that would be the approach. But in majority of the cases, and here we will go by the 80-20 rule, the Pareto principle, you do not need more than 100 data at a time. Whenever you can run aggregations, aggregated queries where you do the averages and counts and sums and so on, and you get that block of data, but you can definitely load more if needed. So paging is absolutely important from the perspective where you do not overpower your users, you do not show them more data that they can handle, you do not overpower your UI logic because it doesn't need to sit in a loop to process a lot of data. And you basically make it easier for the backend to handle those requests. Caching is, if you're not familiar with what caching is, it's basically a storage system where you can take any kind of data and put it in the cache, and it sits in memory database. The retrieval from that is very, very fast. And for the data that doesn't change very often, it is recommended to put it into cache. And the general algorithm for this is whenever you need to load such data, you check in the cache first. And if it is not there, you load it from the database and you put it in the cache for the subsequent request. Subsequent request comes in, you check in the cache, it's there, you use it. And that applies quite well for the data that doesn't change often. The data can still change. So in this case, if something changes and you update it in the database, you go and clear out that cache. Okay. So caching will equal speed and performance, and will also impact scalability, because if every single request and if you have a lot hits the database, of course the database will be running a lot more cycles to get things done. Of course, the actual database will, in our case, will grow and shrink depending on the load. So the response time will remain more or less constant. But still, thinking of an application where you just do not overpower the backend would be the right, just general approach. And applying transactions instead of individual operations becomes important where you need to perform multiple things for any given business transaction. Of course, if you just need to save something in the database or run or an update, wrapping it into the transaction doesn't make sense. Okay. Because for a single operation, if you're trying to update something in the database, if it is not in the transaction, if it fails, it fails. It's not gonna change anything in the database. If you need to load something and modify it and save and then create another object and retrieve that and then link that object to some other relation, you can put it all in the transaction. And that will help with just the overall consistency of the data, of where if something fails, everything gets rolled back. So that's really the beauty of transactions. All right. And that's it as far as the slides. We still have about 15 minutes to chat if there are any questions. I think I see there are several here. And if you guys can think of any additional questions, actually, I do not see any questions. Now, something that I wanted to mention is this. So if you are learning in the process of learning, we do have our courses available on YouTube, and I would start those courses are just on Codeless in general. If you want to, Codeless is our graphical programming, where you do not need to use a programming language. You still need to think algorithmically and think in terms of just structuring your application. So there is a course that you can take on learning how to use Codeless. It is called Codeless Foundation. And we also have a couple of playlists. If you go into youtube.com/backendless, there are a couple of playlists specifically on UI Builder, which is our UI development system. And there are a couple of courses there. Specifically, there is an intro course and there's a master class. All right. One of the questions that came in, could you elaborate on transactions versus operations? A non-technical person. Okay, so what's an operation? Let's talk about database operations. So with database, you can do technically 4 main things, and there are a few auxiliary things. So one of the things is data retrieval, where you send a query to the database using the API, and it returns data. That's data retrieval. For the data that you retrieved, you could have an individual database record. You could modify something in there and send the data record back to the database, and that becomes an operation of update. You're updating an existing record. Or you could take a record that is completely new order is being submitted, and you save it to the database, and it becomes an operation of saving to the database. Or you could just delete something in the database. That's another operation. So these 4 operations, they're commonly referred to as CRUD, C-R-U-D, which is an abbreviation. It stands for create, retrieve, update, delete. 4 major operations. Some additional auxiliary operations that we support could be establishing a relation between 2 tables. That's also a database operation. So individual operations, whenever you send them to the database, if that's what you need to do, create something, and that's the function of that you're executing in your UI, there is really no reason to put it in the transaction. Okay. And here's why. To answer why, let's think about the benefit of transactions. The benefit of transactions is that you can batch multiple operations, namely the ones that I have mentioned, in one batch. And it could be create one object, create another object, link them together with a relation. There are 3 operations in this case. So in this case, let's say you create the first object and you start creating second and it fails. If you were to do it without a transaction, it means that the first object that was created should really not be there, because your intent was to create the whole thing. In this case, if you were to put all these 3 operations into a transaction and run a transaction, there is a guarantee that it's going to be all or nothing. And the reason that guarantee is there is because of how transactions work. So for instance, if any one of these operations fails when they run in a transaction, the whole thing gets canceled. It rolls back. Okay. So that's really the difference between running individual operations and transactions. So I hope I answered your question. If not, please ask a follow-up question. All right. Another question is, would also be very interested in knowing how to implement transactions in Backendless. So transactions in Backendless are available in all our SDKs if you are doing it with code. And there are blocks in Codeless that allow you to create transactions with Codeless, either both in Cloud Code and in UI. To kind of get started on the transactions, what I would recommend is going to the API documentation, select REST. If you were to select, unless you are familiar with JavaScript or Java or .NET or whatever, go to those sections of the docs. And if you're not, start with REST and just read to get kind of become more familiar with the actual vocabulary of what those things are. Okay. And in Codeless, the blocks are, they map rather nicely between the way the REST API works and in Codeless. So you basically create a transaction, you add operations, and then you run the transaction. We are in the process of creating a rather in-depth course on Backendless database, and it's pretty big. So it's at this point it's about 80 videos talking about every single thing. So transactions are going to be one of them. Since it is not there yet, and the documentation is available for SDKs, if you are going to experiment with transactions, just use our support forum. We'll be more than happy to help you with that. Another question, if there are, let's say, 6 operations in transactions, does the transaction count as 1 or 6 API calls? It will count as 1, and from the billing perspective and the limitations that exist in pricing plans, there is a limit of how many operations you can put into a transaction. And those limits are documented on the website, so you will see what they are for the Springboard, Cloud 9, Cloud 99 plans. But you can expand them, so that limit is expendable through a function pack. So if you need to put more, you can do it in there. Now, something else that would be very important and quite interesting. There is an API that is called Deep Save. And before you go into transactions, if your use case is this, where you compose an object in your UI, in UI Builder, or in your application, because it's available for all SDKs, or in Cloud Code, so you basically have this object. And let's say that this object represents a person, and you have name, age, phone number, whatever. And you can attach another object to it through a property and say that that other object is going to be address, and that's the address where that person lives. And address has, city, state, country, whatever. With Deep Save, you can take the parent person object, okay, and you basically send it through the Deep Save API. And then what Backendless does, it basically saves the whole structure in the corresponding tables and creates relations. Underneath the Deep Save API, what it does, it basically goes through the whole hierarchy of your object and creates a transaction for you. So it will save individual objects, it will create relations and do all those things. But from your perspective, you're basically just sending one object that has additional hierarchy hanging off of it. And it will use the transaction internally. So if your use case where you basically need to save something more complex in a single shot, then the Deep Save API is the way to go, because it will basically be very, very simple to use that rather than composing the transaction. Okay. All right. Will this webinar be uploaded to Backendless YouTube channel? Yes, it will be. How is it possible to populate a relation column without running a second query? Good question. So whenever you run data retrieval API, and whether it is done with our SDK and all the native APIs for JavaScript, Android, iOS, Flutter, and so on, or you do it with Codeless, you can identify what relations need to be loaded in addition to the primary object. So for instance, if you look at your data table and you have individual relation columns, let's go back to the same example that I had. User has a relation column address. Well, that example was more at the object level, not necessarily the database, but at the database, let's say you have users table, and there is a column called address, and it goes to the address table. The column name is address. So whenever you load records from users in the API and in the codeless, in codeless you will see relations connector. You basically attach a collection of strings, and each individual string is a relation column. So in this case, you basically put a collection of strings, and one of the strings will say address. And when the data comes back, you will have your address, you will have your users objects, and each individual user object will have a property called address that will contain the address object. So that's how you retrieve relations in a single shot whenever you load data from the backend. Anisa, Hamid, I hope I answered your question. All right, when this new additional course you talked about will be available? I'm going to use this as an opportunity to do a poll, because we were kind of discussing this internally, and I'd love to hear from you, so you can just put that in the chat. And there are two options, guys. Do it the way a lot of streaming channels do it, where you basically, like, every week we upload like 5 videos, and then this gets populated. Or we can do it the way Netflix does it, is like upload the whole thing when it's ready. I'll be curious to hear from you what you would prefer, knowing that it's going to be like, okay, well, we finished on this week. You'll have to wait another till the new episodes become available. So let me know. But since it is a rather large volume of videos, it's going to take some time. My original goal was to do the whole thing by the end of March. Now, with everything else going on in the world, it's going to be a little harder, so it will probably take longer. But let us know what you guys would prefer. All right, so if you are looking for documentation about transactions, I think that's what I just saw a comment that you can find documentation. If you go to backendless.com/docs/rest and then expand database API, and under database API, there's going to be a section that says transactions. That's where the transactions are described. All right. That's the link. You can see the link in the chat, guys. So if you have any more questions, we have a few minutes left. I'll hang around. Right. So as we can see in the chat, opinions have split. Some people saying, they want to binge watch, which I take it as a compliment. If someone binge watches Backendless videos, thank you. I never thought someone would do it, but that's fantastic. And some people say, release as they become available. Maybe we'll do season 1 and then season 2, just as a compromise to that. So one of the questions that came in is whether it's possible to run Backendless application outside our environment. So Backendless, you can run Backendless anywhere where Docker and Kubernetes runs. And to do that, if you go to our GitHub repository, so it's github.com/backendless. And in there, you will see a repository that is called Backendless Pro. So Backendless Pro is the same technological stack of Backendless that basically runs in your environment. And then when you go to the Backendless Pro, you'll see documentation describes how to get it running. Just follow the instructions there. And that's the way to run Backendless outside of our cloud. I think we're done. Guys, I want to thank everyone for joining us today. It's been a pleasure to talk about scalability, among many other things. I think that's one of the most interesting aspects of building applications, because at this point, building UIs with code or without code really is a commodity. But building truly scalable applications requires more than just knowledge and just sheer effort. It requires the right platform. If you were to use something like Backendless, and I think we are that platform that can make it happen for you. Thank you. And until next webinar, bye.